No, that's right. You're from Canada, so you're used to it.
I'm used to it, yeah.
You probably welcome it. All right, let's get started. All right. Okay. You'll have to forgive me. I've been up all night working on code in binge, so I don't know how lucid I'm going to be, if I'm going to fade out or not. But please, let's make it. If you want to speak up, questions, interrupt me, comment, feel free to. There's a lot of slides. This is actually probably something that could be a half-a-day session to go into depth in some of the areas. So I'm going to try to move fairly quick to get the gist of it and get most of it down and not inundate you with too much detail, unless you want to stop me and say you want more detail, and that's fine if we don't make it all the way through, however far we get. So I'm really doing a lot with blockchain and AI, right? So when I first started doing AI or blockchain in 2015, if you go way back, I immediately started with cognitive intelligence, and because I just saw that it was a natural fit from my perspective, and it was shortly when I was actually on LinkedIn and posting cognitive intelligence with AI or with blockchain. IBM was actually posting initially against it, saying that they don't work well together. There's no synergy there and all that. But about a year later, they changed their tune and they merged with Watson and their blockchain group and all that. Well, within the last probably couple years, the steam has been picking up a lot. And people are catching on the synergy between blockchain and AI. So fabric, right? So what are blockchains doing today? So they're financial records, supply chain products, and identities. So obviously there's a lot more, but these are three big focuses right now where people are trying to attack, right? Financial records, supply chain products is probably the #1 use case. You all heard about the food supply chain that IBM's done with Walmart. That's picking up a lot of steam. Kroger is the latest one to join. And that's just going to replicate because everybody will see the value in their food, organic food safety. And then identities. Identities is coming on now more and more. People are realizing that blockchain is a good platform for identity management and provenance and so forth. Blockchain analytics. Now this is, analytics is just what it says. So it's a little bit new within probably the last year. But the good thing that's catching on is not AI. AI's been there a little bit, but analytics, so with blockchain. And the area there is that through blockchain, you get the provenance histories, predictive planning, fraud, and regulatory compliance, right? So blockchain and AI, okay, connected analytics engines, configurable dashboards, predictive models, provenance histories, compliance, external data, that should be data, AI model creation, and trusted AI model creation. So that's sort of redundant. But the idea there is blockchain, you can create models, but a lot of some of the focus is growing more and more on can you trust these models that are being put out. And a lot of it, because there's a lot of, over the last, probably year and a half, a lot of the models, some of the models that have come out have really flopped, especially from Google and Microsoft and so forth. And even you'll see even today in media, bias is a big thing in models. In fact, there was an article recently about where they're using AI for job interviews, right? So it can be a double-edged sword. But they're pulling back on it a little bit because what they're finding is that the models have become more biased over time, and they're actually becoming non-inclusive. Right? So our introduction, what we're going to talk about. Enterprises are using blockchains. So back in 2015, there wasn't anything called an enterprise blockchain. The reason I got into blockchain was because I immediately, when I ripped apart Bitcoin, I saw enterprise blockchain all over it. But obviously, the anarchists didn't believe it. There was a lot of pushback. It took several years. And only until really a year and a half ago did enterprise blockchain actually get separated enough from Bitcoin that boardrooms, VPs, directors, and the general industry, business industry, began being able to talk about blockchain out loud instead of being very quiet because of the baggage that blockchain, the term blockchain carried. But now that's all changing. And I had predicted that 2019 would be when enterprise would wake up. And then 2020 is going to catch on, and by 2025 it's going to be like the transmission in your car and the plumbing in your house. It's going to be something nobody's going to think about until it breaks, because it is a utility, it is a commodity type of technology. It's a backroom technology. It's not glitzy, it's not in your face, it's extremely hard to sell. People fall asleep, right? Hyperledger is really the de facto #1 within the enterprise today. That might not stay like that. There are, I would expect eventually others will come along, probably around 2023, 2024, and maybe probably supplant it. And the reason I say that is because IBM is controlling it more and more and more, and that will probably have a negative effect on its, I won't say its adoption, because Fortune 500 can't go wrong, but on a mass scale, there will be a need there, and something else will come along. And something that will have the benefit of hindsight, right? Food supply, trade facilitation, cross-border payments, identity verification, diamond grading, worldwide shipment tracking. All of these things are real, they're happening now, and most of these are built on Fabric. So a lot of the initial projects at scale choose Fabric. One, because it has name recognition. Two, it has the aura of that it will succeed, that it is production ready, and there's probably resources out there for it. So it has momentum. And close up behind it is Sawtooth. But Sawtooth is more on the edge, more IoT oriented right now, where Fabric is more about business. The general enterprise business. If you think ERP, CRM, right, that's Fabric. If you think about weights, measures, docks, those type of industrial type factory automation, Sawtooth sort of has the edge there because Intel's behind Sawtooth, and they make chips, and they're strong on IoT, and they can get into that instrumentation. They have a market there. Both of them are very strong on the AI as well. So, data association. So the data in the blockchain is really associating participants with timestamps and the business processes. So those three are really synergistic, because the data you don't have to go and find and merge. It's all right there for you. And these are the three key pillars that the blockchain will give you that you want to keep in mind. Now, as far as AI goes, 80% of the AI effort is collecting, cleaning, and organizing. So people are, they look at it like AI is really glamorous until they actually get a job and they start doing the day-to-day grind. And then they realize that 80% of their time is doing this, collecting data, cleaning data, and organizing data. It's not the glamorous commercials of the models and all the things that you fabricate in your mind that AI is. It's really grunt work. Blockchain data already, this is where there's synergy, because with the blockchain is already collecting the data. The data is already identified. It's already in a common format, and it's already organized. So it's like getting a whole, if you're merging and you're beginning to adopt the blockchain, and you're looking at it now from a data perspective, out of your AI lenses, you see where you can nullify and mitigate a lot of that grunt work that you've been doing, because that data that goes into the blockchain is really being already pruned and groomed for you.
How so? Could you explain the difference, like, for, food, right? Like, what is it, the blockchain exactly? How does it make it different than a database or something of that nature? I mean, I understand it's kind of like pulling the record with all the data. Is it like a fancy JSON file, essentially? Like, where it's all, I'm just curious, what exactly the common format?
Yeah, we're going to get into that, the data. So keep that in mind, though, what you're referring to, and if it's not getting answered, then bring that back up.
Cool.
Right? So blockchain data and AI. When you combine the two, what are we talking about? What do we want to be talking about today and thinking about? We want to look at secure analytics service. Okay, that's cool. The secure, because there's a lot of analytics out there, but not really secure. So this is a little new caveat to it. Secure analytics, configurable dashboards. Okay, well that's nothing new, right? But it's new in this realm. Building predictive models. Okay, that's what AI is all about, is being able to predict, right? Creating provenance histories. Okay, this is a little bit of what you're talking about, because in the food, it's all about provenance, right? From the time it's picked in the field, all the hands that touch it, and all the places it sits, how long it sits, where it moves, right? All the way through to the shelf, to your table, right? Which is important. So the key thing in the pilot with IBM and Walmart that got kudos was when the vice president of food safety for Walmart was able to walk up to a store, take his phone, scan a QR code on a package of mangoes, and in 7 seconds have the full provenance of that package, from the farmer all the way through his supply chain, everywhere it went, right? Along with timestamps. Okay. Now that's not something that wasn't being done already, but 7 seconds compares to 2 weeks. Okay. So creating provenance histories, compliance analysis. Okay. Compliance is everywhere, right? Federated learning. This is a hot topic. People are trying to crack this nut, right? Because it's like, how do you scale AI? What's the next mountain to climb? And that's federated. Federated, right? Instead of just having your AI in one box, one room, one data center, right? How can you tap into the world, right? And have it federated and be able to share. There just seems to be that inscalable model that intuitively says, wow, if we can federate our learning, right? 2 heads are better than 1. Well, N heads must be a lot greater too. And then trusted AI. So this gets back to, okay, so now AI is like exploding, and AI is everywhere, and people are using AI. But now the question is, from the compliance, from the auditors, from the people that look at the dark side of things and the risk side of it, say, okay, well, explain to me how it got that decision, and explain to me how this is going to prevent these certain scenarios from happening, right? Because AI, like anything, it's software, so it is susceptible to a lot of zero-day attacks, hackers, poisoning. A lot of bad things can happen with the AI. explicit manner. But even without even an explicit attempt to destroy the AI or to corrupt the AI or to cohort the AI, AI itself, like I said, has a tendency, the learning, to become biased. Okay, and we want to talk about a little bit about that and how that can be, how blockchain can help with that.
Hey, Mark, is AI synonymous with machine learning in your mindset here? Because the security protocols of this allow the pre-programming of AI, but machine learning is kind of a different.
Yeah, so machine learning is a subset
Yeah.
of AI, right?
Yeah.
So when you think of machine learning today, think of statistics on steroids.
Yeah.
Okay, so so the real thrust of machine learning today is in the pillar called supervised learning.
Yeah.
Okay, and it's all about big data, right? More data, the more you can train the systems to a statistical probability,
Yeah.
right? So, for instance, if it sees every grain of sand in the world, it surely can predict that grain of sand, right? But if it sees one beach, right, what's the probability when you ask it a question? Where did this sand come from, right? So, unsupervised learning, right, is about fuzzy, right? It's always about probability. Everything, life is probability, right? But when you think machine learning, that's like sort of like the stage one. That's where we've come from in the last 10 years or so forth, right? And it's going to continue to progress because Moore's law, as it gets more and more on the silicon, more and more data, right? And it's becoming stronger, right? But at the same time, there's another side to AI, right? AI is a very big umbrella, right? And so you have the supervised learning, you have unsupervised learning, you have these things now called GANs, right? Generalized adversarial networks, right? You have these networks of networks, right? And neural networks, right? And then this is continuing to evolve, right? And in the area of federation, you also have another house, you also have a separate side of the house that's called Bayesian. Right? And Bayesian doesn't get its dues. Nobody ever talks about Bayesian. Bayesian is AI, but Bayesian is based upon probability and the unknown, dealing with the unknown, right? But it's extremely effective, right, in the right scenarios, especially in medicine. Medicine goes, because when you don't have access to a bunch of pre-existing data, right? So Bayesian is a killer technology. Now when we're starting to combine Bayesian, right, which deals with making probability and predictions out of with absent data, right? Which you think we're Bayesian, right? We're all Bayesian. We're more Bayesian than we are machine learning, right? Because our machine learning only grows as we age and get experience. But we start making predictions very early on with absent of data, right? And with basically that exploration, trial, and error, right? And it gets pretty good. So AI, what are some of the issues in AI? Well, there's no history, immutable data, right? Should that be maybe? Probably should be. Okay, well, it's actually the opposite. It should be probably think of it more like mutable data because you can mutate the data. Model integrity, biased data, data poisoning, and prediction risk. Okay? I don't know how many insurance companies want to be writing policies based upon some AI model, right? So, analytics on blockchain data. Emerging areas. Blockchain analytics is emerging. Blockbench was one of the very first ones a couple years ago. Was basically an academic paper that did a study, an empirical study, performance study with Fabric Hyperledger Fabric, Ethereum, and Parity. And the bottom line was, the conclusion was, at that time at least, that none of them were ready for the enterprise. They didn't scale. That there was it showed what I found, what came out of it was, the most telling sign was that blockchains, as an enterprise architect, you think that when you throw more at it, you scale up. When you scale up, you get better throughput. But what Blockbench showed everyone, that with blockchains, throwing more at it, you actually go down. So it was anti-intuitive. You can't. So actually, adding more nodes, you could only add so many nodes to a point, and then you started crashing. So that affected a lot and focused a lot of people in that area. I mean, Ethereum's still fighting that with their sharding, trying to figure out how they're going to scale. And of course, Bitcoin, they're trying to figure out how to scale as well. And of course, Hyperledger, they're trying to learn how and figure out how to scale as well too. And most of that's around consensus models for the most part. Temporal queries. So this is something new. Well, blockchains are all about timestamping, right? So what's timestamping? Well, timestamping is temporal. Temporal research has been around for a long time, but not mainstream. Mainstream is, Oracle, SQL Server, right? MySQL, these guys, which is relational data. And it's a different kind of mathematics and a different kind of querying as opposed to these temporal databases. So that's a problem that's being posed. And then off-chain analytics. So this is a big thing that they're doing now. They're pulling data. Like most recently, I think the SEC, right? The SEC put out a big RFP, or they hired a big contractor to start pulling data out of every blockchain, setting it up in their own lab, off-chain, well, actually going on-chain as well as off-chain. So they take it off-chain, dump it, take it off-chain, put it on a supercomputer or a cluster, and then start running analytics on it. Currently, a company, in fact, one of the companies that's really successful right now in that area is Coinalytics, and they use MySQL. So they were one of the first ones to really, as a startup, make headway and start actually making money doing analytics. Probably mostly the very first customers was regulators and law enforcement. Okay, Block Parser is another one. Their focus is Bitcoin CSV dumps. Okay, they basically dump the data and then do analytics on it. Ron and Shamir, they're doing Bitcoin but with graphs, because when you look at Bitcoin from a transaction perspective, it's a graph. And everyone that deals in Bitcoin, they may believe that they're hidden, but they're not. It's a pseudonymous platform. And eventually, if somebody wants to find you, they can find you. And if you're doing enough transactional activity on blockchain, it's very easy to use pattern recognition and sophisticated graph algorithms to get a good picture of who you are and track you. Privacy concerns. When you pull data off-chain, a lot of people are that privacy issues. Okay, and then of course one of the issues is transfer overhead. Pulling it off isn't easy. Leveraging blockchain data, sharing, and AI. Currently, a company called Datum, they're focused on provenance, okay, tracking provenance. Ocean Protocol is all about matchmaking in the sense of the people that are putting it on chain and the people that want to basically think of producers and consumers. Okay. Computable Labs is doing crowdsourcing, so their focus is crowdsourcing, where you are labeling the data, or, you know, it's just what it says. It's a focus area where they're, you know, they want to crowdsource. And then open mind is about data privacy. So these are all focused on analytics. Smart contracts executing AI. This is another segment different than what those guys were doing, because those guys aren't really focused on a smart contract centric approach. They're looking at it as a database, right, holistically, and attacking it from that perspective. These guys are looking at it more from the smart contract perspective, right? So sort of the needle in the haystack, the rifle, as opposed to the other ones that are like shotgun. So algorithmia is about data and models. Neural is doing predictions, and then train AI is about labeling. So these are all just plays on using smart contracts infused with AI to perform, and then how they're attacking in their business model. Secure analytics service and configurable dashboard. Business needs. Okay. So there's a lot of business needs, right, with the blockchain and AI, from trends, time series, aggregation, spatiotemporal analytics, and top-end queries, right? So top-end queries is really just about, you know, maybe there's a million, this query is going to return 1 million rows. I don't care about 1 million rows. I want to see the top 10. Okay? That's all that really matters. That's, for me, that top 10 is 80% of the pie. So I don't care about the rest. The spatiotemporal, this is really about time and space. Think of in the area of like supply chain, time, and geography. So you want to do a query, and you want to see all of the storm events for the last 18 months, right? Well, that's easy to get, but you want to see it in a spatio format. Aggregation. So we're all trying, you know, data, a lot of the, you know, in a large enterprise or in a large supply chain or any type of large endeavor, there's a lot of fragmentation of data, right? So one of the hardest problems is really about aggregating the data, because that's where a lot of the AI comes in, because, you know, when you aggregate, you get new insight. But when you have to look at something over here by itself and something over here by itself, it's very difficult to see the relationships between the two and perhaps gain insight. So when you aggregate, it's all about gaining that knowledge that's embedded within that relationship. So blockchain, how is blockchain what to provide? Well, obviously access control. See, these are already baked in to the blockchain, so you don't, if you're coming at it from an AI perspective, you get this for free, right? When you bring your AI to the blockchain, you already get your access control, which AI doesn't have access control. You have to build that, and that's like completely a separate domain, right? A security model. Well, AI, we don't do security, but with blockchain, you get security model, you get organization identities, right? Who's doing what, okay? You get permission, what can they do? And you get privacy, which privacy today is really, you know, zeitgeist. Everything's about privacy today, right? Moving more and more towards privacy. And privacy is becoming, you know, a liability if you don't address it correctly, especially over in the EU. You can go out of business, go to jail, and it's probably going to come to here. And ETL. So the problem, though, with blockchain is you don't do ETL. So ETL, right, extract, transform, and load. So that's part and parcel to big data, right? Go collect a bunch of data, extract it, transform that data, right, into whatever spread, to CSV, to JSON, to whatever the format is that you need it, as you're aggregating it, and then you got to load it up into a database somewhere, or to a file server somewhere, or to a a warehouse, a digital warehouse, so you can now run your analytics on it. You don't do that with a blockchain. Okay? You can't really do it on a blockchain, okay? As you'll see. So, hemp chain fabric, tightly integrated. Now, this is generic. So, hemp chain fabric could apply to any. So, don't necessarily think of it as an ad, but it's just what I'm working on. So, it's tightly integrated, no ETL needed. Remember, it's fabric, so it's not like a custom. Well, it is customized, but it's pure on fabric. So, it's just think of hemp chain as a brand. Tightly integrated, no ETLs needed, same security model, solution independent, key value store, easy to configure and use. So these are the sort of the selling points with fabric. Data storage. Now we're talking about fabric. So data is stored in two places in fabric. The ledger is a file, okay, and it's not meant to be queried per se, right? Or at least it's not meant for analytics. And then the database. So today you get two databases out of the box. You get LevelDB, which is a little toy database that you can't really run any kind of sophisticated query on it at all. So you immediately move to CouchDB, which is a NoSQL database, sort of like a Mongo, right? And with that, it's a JSON database, document-oriented, name-value pairs, and you can index it, and you can run rich queries on it, okay? So you can get your analytics on it. You can do big data type of analysis, okay? Replicated immutable ledger file. Okay, so that's the ledger file. And that ledger file is made up of a header, a proposal, a response, and endorsement blocks. Okay, made into blocks. Okay, so those are the key components that are in that ledger file. So the header is a lot of metadata, signatures, and so forth. That proposal represents like the transaction that wants to be executed, and its input values. The response is the result of the execution of the smart contract, the chain code, and then the endorsement is the proposals are submitted by clients, and then they're submitted to peers, and peers have to endorse. And the endorsement process is a validation process as well as an integrity check, and then they turn that around and sign it, and then they turn it around and send it back to the client, and then the client resubmits it, and it gets ordered, time-stamped, ordered into a block, and then put back out to peers that did actually do the commit. They do a final check on what's called read-write sets, what we'll look at, and then it gets committed into the blocks, into that immutable ledger file. And then what happens is the most current value, right, is put into that DB. So the DB doesn't hold the history. The DB holds just a snapshot of what it is right now. So, but if you want to know what it was, then you have to go to the immutable ledger. And that is not conducive, it's not really made, I mean, you can do that as you'll see, but that's really a pain, and it's not easy, it's not, yeah, it's not really set up for that very easily. They don't really, I mean, they didn't, you know, it's evolving. The product's evolving, so, you know, they're not thinking, when they were, you know, they're doing 1, 2, 1, 1, 2, we're at 1, 4, 3 now, and we're working on 2, all right? But back, they weren't thinking about analytics. They were thinking about, at first they weren't even thinking about the queries so much, right? But then eventually they evolved, and then they say, oh, well, we got to get beyond LevelDB, these little name value pairs, because people want to be able to really query this stuff and get information, right? So let's throw in CouchDB, a NoSQL database, right? So we replicate the data snapshot, put it up there into the CouchDB, and now folks can query that DB and get the data, because they can't be querying the immutable ledger, right? Well, for one, they don't really want you to be doing that because of CPU cycles. Because the only way you're going to get to those ledgers is through those peers. And those peers are busy taking transactions, doing endorsements, and doing commits, right? So they want the throughput. And if they got to go and now start handling all these queries, that's an issue. So it's not suitable for analytics queries in a snapshot.
Hey Mark, is there any good solution for time series analysis then, or?
When you say a good solution, there are. There are, but they're coming. We're only at the first phase. Yeah. So like I said, the temporal queries have been around for a long time. So that's going to be the next evolution. That there'll be more and more will be moving. In fact, like for instance, that's what I'm working on. One of the things I'm working on is in that area. So there's like a couple different. There's like 4 different avenues that are effective. But one is like a point-based query. So and the point-based query, because it's temporal. So it has a whole different type of calculus that you want to apply to it, as opposed to the calculus that you apply to relational databases, right? And when you do that, because the research has been there for 20 years, I actually have a paper on it, well, several, but there's one really good paper from University of Arizona, and for example, they show where you can go from like 200,000 disk IOs down to like 6,000 disk IOs to get the information that you need. And it's all about when you're looking at it's all about the joins, and that's both data structure and calculus. And there's really two camps on that. And that's going to be coming. Now, then there's the database schema. So the schema is sort of really maintained in the peers and in the smart contracts, because that's at the application layer. That's defining that name value pair and the JSON, right, that comes out. So it's application specific. So there's no standard schema, right? For example, industrial hemp. So might look like hemp attributes, license and role, just 2 attributes, right? So you would find this as a data structure. You have a key called hemp, and then you have a value, and it has an attribute called license, 1, 2, 3, and then a second attribute called role for producer. So that would be a schema. When you run a transaction, in this case, like a ownership transfer, okay, this is where these reads and writes come in. So there's these are 2 different data structures and algorithms that are maintained. So they're basically the before and after. And in the ledger keeps both of those. But in the database, when I say database, I'm talking about CouchDB, the things that you and I will be accessing as users. The ledger is what the peers write and commit, what we would think of when we say the blockchain, the ledger. That's where the write set, the read-write sets are. So when the reads are what comes in, and then the writes are what goes out, but they're put together, and they're put together in a block along with all that metadata we saw, and that's what gets put down, serialized with the hashes, linked by the hashes, right, in the ledger. And that's why it's hard to get at. But that's where the data, for what we're talking about today, that's where the gold is, okay, because that's where the temporal data is, okay, for what we're talking about. What we're trying to get to. Okay, design and architecture and implementation. So there's a lot going on here, and it pretty well sums this thing up. So let's take a look at this. So we have our dashboard over on the right. I'm sorry, left. Okay, and then we have our secure hip chain container, the big block, big outer block, and inside there, there's an analytics container, Docker container. You can think of the hip chain like a pod, and then two containers inside that pod, one being the analytics container and the blockchain peer, but it doesn't have to be that way. The analytics container, the analytics piece can actually be embedded right in the peer. It doesn't, it doesn't have to be. And they can also be completely isolated from each other as well. But for this diagram, let's just stick with what we have here in the one container. So at the top, the analytics container, in the top left, we have authentication, dashboard, management, and service APIs, right? And it executes Fabric SDK, authenticate. So you see the Fabric SDK. So this is our peer, our blockchain node. You might want to think of that. Down at the bottom, there's our blockchain ledger we've been talking about. Okay. Our state DB, that's our couch database. Okay. And we have our SDK. That's how we talk to that peer. Okay. So then we have our analytics server. So requests come in from the client, which is a browser with a dashboard. Okay. And that is wide open source. So we're building components from various open source packages that can be used from D3 to a lot of different graphic packages that we'll see. It's REST-based, so that's standard. It's extensible, right? Let's see. It's secure as well. No ETL. Okay. But there's two key components that make this thing work. Okay. And that's the hemp chain schedule block processor and the hemp chain real-time block processor. Now, both of those are the same thing fundamentally, but their implementations are different because they can be applied depending upon the need. So, starting with the scheduled bulk processor, it is based, it's just what it says, it's scheduled, so it doesn't run all the time, and it actually can be isolated outside of the peer. Okay? So it periodically goes out and reads this block ledger, okay, and decodes it, gets the read-write sets, and then puts those into CouchDB. So that now we can query CouchDB for that data that's latent and locked up inside that ledger. Okay. Now, the second implementation is the real-time mode. So this one actually is working off of what's called the system, an extension of the system chain code. So as these transactions happen, it's picking them up, decoding them, and then writing them out to the state database. So the end result is the same. It's just that the real-time bulk processor is running real-time in that peer, so there's a direct hit on the processing capability, the processing the CPU cycles. Okay, so you have to understand what's your use case and what's your throughput, and whether you would want to use it or you would want to use the scheduled bulk processor, which is outside and does not affect the peer. So it doesn't degrade the performance at all. Okay. It just, but it's not real time. Okay. Questions on this? This is the heart and soul. This is what's hard. This is what you can't do today. Okay? And this is what makes the analytics work, or those two components, because they They go out, they read that ledger, they decode those read-write sets, and they reformat and put them into JSON, and then write them out to the state database, and then they keep that state database in sync with that ledger, so that now you can do the analytics.
So that's effectively your ETL process.
Well, no, it's not. Oh, okay. You could look at it semantically. You could say that. Yeah, in a micro manner, right? Yeah. So the ledger block process that I was talking about, ledger queries are not supported. Okay, so that's why we had to build that. Stores the ledger read-write data, the read-write sets data in the database, and then the two modes. There's the scheduled ledger processor and the real-time ledger processor. Now we have query creation flow. Okay. So these components that we're looking at, when you build a query, we're really talking about these different components. We have keys, filters, values, aggregate functions, and user parameters and transformation, and then views. So, try to break this one down. Let me try to attack this way. So think of, when I talk about this, let's think about our query is compute the average tonnage of hemp shipped from Texas to various states in the past 6 months. Okay. I want to know the average tonnage of hemp that Texas has shipped to the various states over the last 6 months. So the key attributes would be, let me just read this. In specifying the query, the keys represent the group by. Okay, if you're familiar with SQL, that's your aggregator. You want a group by. Okay, this allows the partitioning of the data into multiple segments on the aggregations to be applied. So, for instance, in the above query, the source of shipment is the key attribute. The source state of shipment is the key attribute. So in this case, it'd be like Texas. The value attribute represents an aggregation that's performed. In this case, would be the tonnage of shipment as the value attribute. And then the filter attribute filters out the data based on the user specified criteria. And in this example, there are two filter attributes. The destination state, right, which is going to have to be one of the U.S. states, and the shipment date, and the filter there will be within the past 6 months. So there's two filters, one key being the state, and then the values is a set of all states that belong to the U.S. So anything that doesn't fit those parameters or attributes are thrown out. Now the aggregators and the formations. So the aggregators are functions that are applied on top of the segments of the curated data. So in this query, the aggregator is a function that's computing the average tonnage. Okay, so this would be the functions like it could be count, sum the total, percentages, median, standard deviation, and so on. So that's the actual function that you're going to be applying to this data once it's been curated and segmented and presented. So it's going to run through these aggregators. And then finally you have your view. So the view performs performance-related challenge on the query process is to parse the JSON documents, retrieve the key value attributes as specified above. So couches, we use the couch DB views, okay? So there's nothing new there. And that's why we want to get that data from that ledger into couch so that we can actually use the views given a set of attributes. So there's a whole process that goes on because the views are dynamic and they're made out of a map. So the process will actually try to find a map that fits the criteria, and if it does, it will use that view. If it doesn't, then it has to build a new view, which is going to be a map of this data, or these attributes. But this is how the analytics is working, so much different than what you find in a standard SQL query. Endorsing peer load. So this is critical because that data resides in that ledger, and that ledger is on every peer, right? There's no way to get to it without either, like we say, either reading it outside as a file, okay, or being embedded and co-located with the peer, which will affect the peer's load. So you have to look at transaction volume, right? So if, for instance, hemp harvest would be low volume because that doesn't happen that often. But it might spike, but even then, it's not going to be the same kind of transaction volume that we're talking about, let's say, for instance, with a national retail outlet doing CBD sales, where that's going to be a high volume. So with the hemp harvest, you could probably then want to use the real time, right? Well, I don't know. I mean, you have to experiment. And I guess it comes out to each application and user what you're actually wanting to derive. Because if you really need CBD sales real time, right? Then you're going to want the real time processor, block processor, so it's sort of, so it's not necessarily correlated, right, in this case, because the hemp harvest would be more suited probably for the offline, for the scheduled. But then maybe not, because if it's peaking, and those harvests have a temporal component to them that they have to be performed within a very short period of time, then you might want the real-time block processor on that. Whereas the CBD cells, right, you really don't, a lot of retail outlets can run their numbers in a 24-hour period, or a 12-hour period, or an 8-hour period. Or even a 4-hour period is fine, or a 2-hour period. So it's just, you really don't need, so you probably in that case, because you have transactions coming in, you want those endorsers to be doing their job, right? And then every couple of hours, your offline reader can come in and read and then catch and then update the data. So that's probably how it would work. So you can see, you can go both ways depending upon what it is you're trying to do. Predictive models. So now we can get data, we can put data into Couch, we got views, we can run these temporal queries, we can ask intelligent questions, and we can get views and dashboards, right? So, what's there? Well, it's all about the history, okay? Because otherwise, we already have our snapshot. So if it's just if you just want to know now, then you don't need the analytics. But what we're getting at is the history, okay? Because that's what provenance is. Provenance is history. Right? Where has it been? Where did it go? Okay? Machine learning, predictive analytic models are all about the experience, the history. Right? Being able to look at the priors in order to ask a question to say what's it going to do tomorrow, or next week, or next month, or this quarter. So machine learning with blockchain data. In this case, we focus on a use case called supply chain shipping delays, okay? Which is a big deal, because people pay a lot of money on delays, and it has a ripple effect in the whole supply chain. So what are the essential elements here? We have exploratory analysis. Now this is focusing now, remember, on the predictive model. So we're building AI here. We're now attacking our AI problem. Okay? So the very first thing you do in AI is exploratory analysis. You've got some data, but you don't really know anything about the data, so you do exploratory analysis. So you need tools, right, that will allow you to go in and introspect and look at that data. Try to get some kind of feel for it. And what you're looking for to do is to come out of that to the next stage, which is feature engineering. So you can look at data, and you might have 1,000 attributes of that on that data, 1,000 different data points, each one unique. But you know that you may know from experience that there's a half a dozen of them that really matter. And those 6 are the ones you want to find. And even out of those 6, there might be actually 3 that really matter that you thought you needed 6. But when you do with the right tools, the tools will tell you, no, dude, you only need these 3. With these 3, you're going to get 95% of what you're after. Everything else is just going to be, not of value to you. Now, once you have your features and you've done that engineering, you begin building that model. Okay? Once you build your model, okay, that's really about choosing algorithms, right? And that's going to be based upon your features. So there's typically categorical model or categories, right? I'm getting a brain. Help me out. Basically, classification and regression. So you want to classify something. Usually that's categorical, right? Oh, continuous is what I was trying to think of. Continuous. So think of continuous as like temperatures, right? Numbers, right? Housing prices, right? So these are continuous values, right? And you use typically regression for those, and you would use classification if, say, you're looking at breast tumors, right? Is that a tumor, that cell? Yes or no? No? Okay. What's the temperature, what's the prices on these houses in that neighborhood, right? That's not categorical. That's going to be a regression. So you're going to build your model, and then you're going to start training your model. So now you take your data, you're going to split it up into partitions, because you don't want to use a little bit of the data for training, and then you use some of the data for testing as well, right? And you can use then some of the data also for augmenting too, if you need to. And then you're eventually going to operationalize it, and that means take it out to production so you can start asking questions. So primary machine learning data source data. So we have our blockchain data. Right? Data augmentation. In this case, for this use case, we're looking at weather data. So you're not going to rely just on blockchain data. That's the centerpiece, but you're going to want to augment it. Okay? You're going to want to bring in external data as well. There's no way around it. So in this particular case, weather data. So you might say, well, Mark, we're going to actually just write a smart contract, and we got an API, and we got a contract with a supplier, and we're just going to be putting the weather data on the blockchain too. Okay, great. Now you don't have to go outside. Okay? But for this use case, we do. And this is what I want to show you, that there's nothing wrong with augmenting your blockchain data. So here we're augmenting it with weather data from NOAA and location data from OpenStreetMap. Okay. Because when you think about it, the core is that blockchain data. That's the data that really matters the most for us, okay, in this use case. So the HempChain AI Studio. So this is basically a workbench. There are several workbenches out there today, open source, proprietary. Everybody's getting to the maturity model on AI is not writing, code so much. You still write code, but it's not really about a bunch of shell scripts and putting it together at the code level. We're much more mature now with basically AI ID, just like coders today use Eclipse, IDEs, right? We don't grab a terminal and write, 100,000 lines of code. We use an IDE, right? So same way with AI. AI is moving to IDEs because a lot of the models and algorithms and so forth are maturing to the point where they're components. They can be purchased, right? They can be leased. They can be rented, okay? And you just need to drag and drop them and connect them up. You don't have to go out, and this is really the trend. It's not about going out and reinventing the wheel. Somebody's already done this. Somebody's already trained a model, okay? And if we look back a few of those slides that we were talking about in those blockchain companies, that's what a lot of those guys are doing. They're trying to get to a point where, like crowdsource the models, right? So who has the best model? Now you get tokens, okay? So it's about reusing. So with HempChain Studio, so some of the core things you would want: SSH to get in securely, HTTPS, secure REST. You don't want man in the middle. You want to be able to have an open, robust ability to log in from external sources. That's OpenID and OAuth 2, and you want to be able to have admin policies. So these things are not unique to blockchain, but they're something that, in this context, that you want in your solution. So what are you going to use these tools for? You're going to use your data exploration. You want to be able to have rich variety of data connectors. Everybody talks JSON data, so you don't want a proprietary data format. And you want it to be as open as much as you can, starting with Python, Java, and R. Those are really the big three, probably in that order. Maybe Java and R, you can debate that. But definitely Python is heart and soul of AI today, and right on its heels is R. And in the enterprise, there's a lot of Java as well. And then visualization. So there's not a whole lot of visualization that's coming on board now in the area of AI. There's obviously a lot of visualization in analytics, right? But in the area of AI, visualizing AI is something new, but it's happening. So some of the open source tools, as you can see, Matplotlib and Seaborn and Bruno came out of IBM, and ggplot. So all of these are open source, and they all have a little bit different flavor. Some of them specialize in different kinds of plots and graphs and so forth. Some of them are just general workhorses like Seaborn and Matplotlib. Obviously, you can think of GeoPlot. Well, okay, that's got to be a lot with GIS based, and it is. So here's an example of a visualization for the mean shipping delays from the United States, in this case to Turkey. So when you click on Turkey, you get a pop-up, and it's giving you a prediction. Okay? It's telling you the delay. So this is the kind of output that we're looking for in the end result. So this is not a static database, right? This is a real-time query going to the analytics engine, which is running on an AI model, And this is what it's telling you, based on what it knows. And here's another example, and this one's using weather, okay, in the United States with a map as well as a bar chart. Model building. Blockchain data, format suitability, feature engineering, and finding attributes. Those are the key components for building your model. Okay. So format suitability, a lot of times you get the blockchain data, but you might have to format it, the data, a little bit different based upon what it is you're trying to accomplish, right? In order to get to the feature engineering. Sometimes you can just skip that whole part altogether, right? And then the feature engineering is all about finding the right attributes, because it's those attributes that are going to be what's going to drive the results of your predictions. So in feature engineering, that's where I was saying continuous variable is our shipping delay. In this case, what we were looking at is a regression model. The prediction label was the delay. And regression algorithms, you have a variety of regression algorithms, right? There's random forest, decision tree, linear. So there's not like one shoe fits all. And a lot of times you don't know which one of these are going to perform the best. So that's why you want to be able to evaluate them and compare. Okay. But you don't want just one. So if you want something robust, you want many. And you want the ability to evaluate them and compare them. And that's what this particular graphic is showing you, where it ran, the top line is a linear regression, the middle is a random forest regressor, and then a decision tree regressor. And the decision tree actually has the best performance. So that would then be the model that you would go with. So your pipeline. Your pipeline is all about exploring, testing, staging, and production. And there's a lot of effort in AI today outside blockchain that's moving to this, because this is where you get the auto ML. This is where it's like the continuous integration, continuous deployment, but with AI. And the only thing we're missing is the feedback loop, which we'll see in a little bit. Once you deploy the model, real-time shipping status inquiry, so it's not a batch job, right? A RESTful endpoint, it should be REST API, and then there's a status inquiry website. So it's basically just a single landing page that's implementing that API behind it to execute that particular query for the model, because every model is going to be different. So this is what that website would look like, something very simple. And you're sending the query to it along with your payload, and you're getting back your delay, which is a prediction. So these are not static data. This is what the model is predicting based upon the attributes. Now, models get old. There's problems, right? You have to retrain these models. You can't just put one out there and forget about it, right? Performance degrades over time. Patterns change. So you need to monitor the performance, and you need to have the ability to set alerts. And when those alerts go off, then you need to go and retrain. So what's missing here is that piece where to close the loop, to actually be able to go back and do the retraining automatically. So there are efforts in the AI world today that are trying to perfect that complete feedback loop. We're not there yet, but with blockchain will help that a lot when you think about it, because with the next evolution is putting the model performance on the blockchain. So now you have AI for AI, right? And now you can have a continuous loop where the model is continuously optimizing itself. Provenance queries. So you do your provenance queries off of transaction history. Fabric has the history. There's an asset life cycle. Provenance query use cases are compliance, visual. These are just three: compliance, visualization, and reporting. Just attack those three initially. So based upon temporal queries. So right now, the ledger is always, like we said, is very inefficient at temporal queries because, for one, the data is distributed. It's in time-ordered blocks. There's hash links, and there's no temporal indexes. So in order to get data out of it, you have to basically crawl every block, and that means a lot of irrelevant blocks that you've got to access. So that's a problem. Now this gets a little funky here. I'll try and move through this. What's a strategy? This sort of goes what you were talking about, right? Okay. So the key value data store with our notation here. So basically we have key, value, and time. That's a pair, a tuple. The E is a set of keys, and the theta is an interval. The B is a set. That's all the blocks that hold the key. And then the next set is the blocks of keys that with the times. So Fabric has an API for reading the ledger. It's called Get History for Key. And you pass it a key. And it basically goes down and accesses the block, all the blocks, a block set for that key. Fabric maintains an index. So you can stop when you have T1 and T2. You don't have to, but the thing is, you have to, as you see, you have to access all the other blocks up to that point. Which is very inefficient. But there's a way to get to it. So the strategy that we're employing, there's actually two. This is one called the native indexing transactions. Indexing native transactions. So you collect all the events, the keys and theta, that's our interval. We ingest the keys, a pair, okay? In this case, it's without any transformation, okay? Which is the key in the interval range, and then a set of all the keys in the interval range. We call that the indexing intervals. There's no data there, though, so we don't know any assets, but we've got indexing intervals. Okay? Now, this does impact the Fabric throughput. Because what you have to end up doing eventually is calling in GHK, and that's the calls. But it's targeted. You're only accessing the blocks in the interval. Okay? That's important. So it's much faster, way faster, less resource intensive. But you still, you're still executing these calls, and when you execute these calls, you're hitting the processor for those endorsers. The second method is indexing by modifying the transactions. So this has no impact at all on Fabric. Okay. So again, we have our tuple of our key, our value, and our time, but now we're transforming it, doing a transformation on it, okay? Throwing everything else out, but we're keeping this pair, which is our key in our index interval range, with the value this time and the time. So theta is our indexing interval, and T is in that interval. That's critical. That's what we've transformed to. Okay? And then we only store the transformed pair. So now we don't have to go back and hit the pair. No additional transaction, but there's a cost. Nothing's free. Okay? You can't access the asset, right, with the call. So you have to call across the key and the interval for each indexing interval. and then collect the output. Okay. But we have the calls that we need. Okay. Logistics. Whenever a shipment S is placed, this is what we're looking at. Whenever a shipment S is placed in a container, that's our use case that we're going to use in order to test these. It's placed in a container at time t, the key value pair, right, S, container, that's an L for load, and then T for the timestamp, is inserted into fabric. Experimental evaluation. So our use case is supply chain use case, shipments placed in containers, containers transported by trucks. Okay. Whenever the I guess I missed that slide sequence. I'm sorry about that. So I'm repeating. So whenever the shipment S is placed in the container CT, right? So we went through that. That's loading. Now the opposite, when the shipment is taken out of the container at time T, there's another pair. Okay, shipment container unload timestamp is inserted. Similarly, and also there's the same pair for the truck, loading the truck and unloading the truck. So we're capturing this. So this test was performed with release 1 on a single peer with a Lenovo laptop, 4 gigs of memory, Intel i5 with consensus on. The data set was synthetic data consisting of 400 shipments, 100 containers, and 20 trucks. The number of events per shipment and container was 2K with a uniform distribution, right, for a total of 1 million total events. The time range went from 0 to 15K, and the keys are not shared, so every key is unique, and we execute in batches of consecutive events, not randomly, but in consecutive events, batches. Okay. So we did a temporal join on the query. So given the duration omega, from time start to time end, for each shipment, we want to find out the number of trucks, a set of trucks rather, that transported the shipment at any time queried during omega. Okay. This requires retrieving the shipment and container load and unload events in omega and taking a join over those sets of events. So for both models, indexing intervals of length 2K and varying the interval omega from 1 to 10 and 140 to 150. Okay. This is what we got. So the linear line going up is no indexing. Okay? The purple line on the bottom was the very first method that I showed you, the INT, okay, where we did no transformation. And then the green is the INT where we did a transformation. So you can see they're linear, they're stable, but there's a little slight difference in performance there. But it doesn't change over the query interval. So you can see how powerful, how important that is. Okay. You're not going to find this anywhere else. Well, I mean, you might find it somewhere else, but this is not, it's not out there. Compliance and analysis. So that's the query piece. You can see there's very involved. Okay. Instrumental task. Risk identification, violations, fraud, audit. I'm going to have to speed up a little bit. Okay. Ledger metadata, contents, timestamp, recording, endorsing. Right? Unique challenges. Key value pairs. Data can be complex JSON documents. Schemas defined in smart contracts. You need the schema in order to do analysis. Multiple transactions modify an asset over time, but compliance must consider an asset state evolution, the metadata, and the time-bounded correlation. So compliance is not something that you would think, oh, this is really easy, just, you know, it's simple. No, it's fragmented. It has to be pulled together. So there's a compliance engine. The compliance engine does the analysis and the audit of that data. It's rule-based. It's obviously a separate component connected either through cloud or on-prem, peer integrated, and has command line. It applies rules to the data, but the problem is it can't get to encrypted data. So that's a problem. The identities of the schema of assets, it identifies the schema of the assets by introspecting the smart contracts and metadata, and then an analyst actually runs this thing and has to define those rules. Those rules can be defined in JavaScript or in a natural query language, which is like a SQL. But it's for basically building decision tree rules. Okay. So on execution, it'll connect to the peers, extract assets, do metadata from the blocks, stores that in memory, iterates over the assets. The results are then put into CouchDB and then displayed on a dashboard for an analyst. Now you can use the ML to go against non-compliant assets looking for patterns. Okay. So this is what a report would look like. You have a total of 14,500 assets, 8,500 are compliant, 6,000 of them are non-compliant. Okay. And you have your timeline of when, of how they varied, compliance varied. Next is federated learning. So federated learning is about blockchain integration, model training, data distributed, classification, regression, learning-based tasks, and aggregation is required. You have to aggregate. You have bandwidth constraints, data provenance, and you have your blockchain. Because everything's not, it's on a distributed network. Data provenance means that each node has their set and they own that data. So you have to get around that. The data partitioning. You have your global model and you have these local models, local data. So all the nodes are local, right? But it's going to be an aggregator, which is the global model. Okay. You have to do sharing of the model parameters, and you have an aggregation manager. So the aggregation manager is going to combine updates and produce this global model, and then it's going to return back to the local models, the results, basically the weights, and then you're going to do iterations. So this is the focus of what federated learning is. Now you implement with multi-layer neural networks. You can use basically either a convolutional neural network, feed-forward neural networks. You can even use a support vector machine and decision trees. Okay? But you're going to use a multi-layer neural network to perform this. Design. Distribution among agents. So you have these agents that are running these local models. Right? You have to think about the model architecture. You have to think about these hyperparameters. Okay? These are like the attributes of those models. They all have to be common. Right? They have to be synced up. And then you have to think about how you're communicating and executing. Are you going to do it? You execute either synchronously or asynchronously. Okay? So when you're doing it synchronously, that means that the aggregator is making the calls out, and then it's waiting for all the agents to run their model, their rounds, and then bring back what they have, and then do the aggregation. Whereas with asynchronous, you're not waiting on any particular agent. You have a network-based gradient descent, okay, and you have and then the aggregation algorithm. These are the things you have to nail down in the design. So with the data distribution, you're training data partitions. Each one's independent, identical distribution. You have to look for skewed classes or labels. That could be a problem. And then you have to, if that is there, then you need your aggregator to do compensation for it. And then you have two basic design patterns, either horizontal partitioning. Okay, that's basically where everybody has the same set, same parameters. Basically, think of it from a feature set. Everybody's working on the same features. Okay? And you have vertical partitioning. That's where you're going to break it down, and you might have certain oones working on certain features. And not everybody's working on the same feature set. Two different modes. So you have a configuration, layers, and neurons. Training dependencies. Your hyperparameters, your number of epochs, mini batch sizes, model update frequency. Training algorithm. Your Hyperledger parameters are shared. They're provided by the aggregator. Okay? You have weight update methods, synchronous gradient descent, and the slowest agent determines the speed. Okay. In a synchronous mode. So if you're running asynchronous, then it doesn't matter how slow a particular agent is. But you have other issues there to worry about because eventually you have to aggregate that particular agent as well. So you have to compensate for that. In the asynchronous mode, the aggregator is not waiting. The aggregation algorithm is the key. You have multiple rounds of protocols, and the aggregators should be adapting. Parameter sharing. Fixed number of training rounds, local shares, aggregator weighted averaging. Results are sent back to the local agents. Local update, cycle repeat, converge, halts the cycle. So the converge is obviously happening locally, but it doesn't matter locally because it has to happen. But it's the same pattern. So now you have the concept, when you are federated like this, you have to deal with the balance between data and the rounds. So if you have more rounds, you can use less data. Okay? You have to think about bad agents. Okay? The blockchain helps mitigate that part of it because you can use provenance, right, on the sets, shared ledger, anti-tamper, permission constraints, and you can run random audits. So you have control, whereas without a blockchain, you're doing federated learning, you're going to have these problems. Blockchain for AI, for trusted AI. We're almost done. Okay. So AI is gaining importance. We all know that. Right? Blockchain helps how? It helps track the AI process. It helps with access control, privacy, the order of exchanges, and the immutability of the ledger for tracing. Order of exchanges is important because that's how work is distributed, that's how models are decided, hyperparameters are doled out, data sets are brought in, changed. Okay. Illustrative requirements for trusted AI, connected trust. We want a lot of, doing AI is expensive, so we want reuse and composition. And we are moving in that direction. We talked about that. Confidentiality, trusted sharing, verification, auditability, provenance, and fairness. Tracking AI with blockchain. Key constructs, your participants, your data sets, your models, and your operations. And this is what a dashboard output would look like for federated learning. So you have each one of these are participants, and each one has their own model that they're running with their metadata. And then their iterations, when it was last modified, the owner, the participant, the type, and an identifier. Future work, where the future can go is advanced visualization, natural language interaction, personal agents, agent oracles, point geo temporal queries. We talked about that. That's an area that we want to improve on. And graph processing. There's no graph processing today being done. And there is graphs within this temporal data because not all of the data, temporal data can actually have branches. And that creates these graphs. And you want to build it. There's no way today to really deal with that because we're looking at temporal data in a linear fashion, timestamp. So summary, what we talked about, the analytics, transactional history, timestamps, provenance, compliance, trusted AI, federated learning, future direction. Thank you.
Thank you, Mark.
You guys held out.
Thanks, Mark.
All right. My pleasure. Did you get anything out of it?
You've made great strides in many ways.
Yeah? Okay. Did you find it of any value?
Yeah. There's a lot to digest.
Lot to digest, lot to unwrap?
I have a couple of questions for you.
Yeah.
I have a friend from Colorado that was asking about, Brave, right? The content model that they're trying to kind of capture. He was asking about using Fabric to create a similar solution, like a Patreon or a Brave style monetization strategy that would be able to be wrapped into a browser, I guess.
Yeah.
So he was asking me to kind of vet Hyperledger as an option, or Fabric as an option for like managing those payments, I guess.
Oh, yeah.
Yeah, he wants to use like a conventional Square or something like that to accept money from the readers or whatever, and then pay people.
Oh, it's perfect. Yeah, I can tell you right now, yeah. Yeah, in that context, because it's a private, it's permissioned, right?
Right,
Yeah,
right.
then this would be, yeah, perfect.
Interesting.
Yeah. And in fact, in version 2, they're baking in basically an EVM,
Nice.
okay, as well as tokens.
Cool. And you can build tokens.
But even without that, you can do that. You can do it now. In fact, out in California, there's a company that's been using Fabric for marijuana payments,
Cool.
for dispensary payments.
And are they?
He actually was a dispensary,
Right.
and they brought in Hyperledger Fabric to be their payment, and it was so successful that he got out. He sold his dispensaries.
Nice.
And he became a SaaS service for California dispensaries
Nice.
doing this.
So,
But the way he did it is external data to the banks,
right.
and then using smart contracts. So if the external the banking system feeds into the smart contracts, and then the smart contracts feed back out to the payment systems.
So the exchange is crypto, or the exchange is money?
Yeah, the exchange is fiat. It's
Yeah,
yeah. So it's just that he sits in the middle
yeah.
and does all the processing. But the actual payment piece is done by the third-party house, and the actual financial portion of it, underwriting, so to speak, right, is done by banks.
Yeah. Well, the challenge that banks are running into now, and it's kind of world that I live in, is banks are not putting crypto on their books.
Right.
Yeah.
But the reality is their funding, they have bank businesses that they make loans to
Right.
that trade in traditional money, but part of their assets are crypto.
Right.
So then how do you value that company?
Yeah.
And
Yeah, it
that's-
makes it tough.
Yeah,
Yeah.
yeah.
Especially when Bitcoin is going up and down, right?
Yeah,
You know.
yeah, and it's so if you're federally insuring a business up to $250,000,
And then even by face value, you can't go by that, because how do you know you can liquidate it?
that's exactly right. So,
You might have $1 million, but who are you going to give it to?
yeah.
Right.
So Mark, actually, I've taken on a consulting role for the Texas Bankers Association, and I'm sitting on 7 university boards
No kidding.
and business boards, and helping with their schools of banking, finance, and so we're trying to learn more. They're asking me to help with the curriculum on advancing around AI, crypto, these forward-looking things around.
Wow. That's
So
fantastic.
part of my job, Mark, is meeting with people such as yourself.
Yep.
And ultimately, maybe having guest speakers come in, and just how is blockchain gonna impact finance? And we already know these little segments, it already has.
Yeah,
But, AI will, and it's really the retraining of people.
yeah,
So 5 years down the road, you're gonna be banking a little bit different.
absolutely.
You're not gonna have fewer employees, they're just gonna be doing different
Right.
roles.
Yeah.
And so how do we train for that and the people?
Get ready for the digital wallets and,
Yeah.
and tokenization of assets and,
Yeah. And
yeah.
the broad understanding of the reality of the financial channel, and it's still governed by the FDIC and the FCC
Yeah.
and everything else,
Yeah,
but understanding that in the realm of, it's a different world,
yeah.
you know. so
And
it's
then
interesting.
right now, hot thing is stable coins,
Yeah.
right? I
Yeah.
mean, and then asset tokenization, right?
Mhm.
So, I mean, that, in the banking world, right, I mean, that's huge because, there's, you know, a lot of it, I mean, there's different modus operandi, but everything from balancing liability, you know, liability control,
Yeah,
to improving what the books look like,
yeah,
to raising cash.
yeah. Stable coin works there,
Yeah.
works well,
Yeah, well, as a vehicle for the asset tokenization,
yeah,
because, you know, right?
yeah. Completely agree.
Yeah, there's an interesting model there.
Yeah, so thanks for letting me stick my head in, enjoyed it. Sounds like you got a lot of insight.
Anytime.
Yeah,
Anytime.
yeah.
You
So-
know that, anytime.
Yeah, so our little entity is still doing well. And, so after my son spent 4 months in the hospital, and $5 million later, we're gonna start him we didn't know if he'd survive, but he's actually gonna start college in this coming semester.
He's doing good then.
He's doing better than the doctors ever said he
Wow.
would, yeah. Yeah.
That's fantastic.
Yeah. So,
Fantastic.
so life's good, but you adapt and you change, so I've had Pete and Mike and another guy I brought into the company to kind of, I'm just kind of taking over at Chairman Emirates.
Yeah, yeah.
And making sure that the other things in my life are running well, and they are, and I'm glad to see you're doing well.
Thank you.
Yeah.
Thank you.
Mark, I'll be in touch with you, bud.
All righty, looking forward to it. Everything, make sure I got everything. Yep. Good, good.